Welcome back to Workshop Friend, and I'm continuing my work on the Meddings pillar drill and installing a variable frequency drive with a three-phase motor. So last video I fitted the pulley to the motor, and then off camera I worked on the other pulley. The other pulley goes on this shaft here. This is actually a geared head, and what I discovered was that I rebushed it, turned it to size, and then discovered that this shaft is slightly damaged. So we'll have a closer look at that. So you can see that this has been messed around, and what I hadn't anticipated was that I turned this to the right size and discovered that it's just not going on properly. So I'm using the opportunity to actually address an oil leak. There's an oil seal down here, so I've drained the oil out and dismantling this, I'm going to get this shaft out. The first thing I'm going to do is true up this so that it's a nice fit on the pulley, get that problem sorted out, and then see if I can get that oil seal out and find a replacement. If ever you find yourself dismantling a geared head on a Meddings drill like this, be careful of the two spring-loaded ball bearings. In my case, they flew all over the workshop. So while I was setting this up to skim this diameter here, tidy it up for the pulley to go on, I thought I'd just check the run out, and I've discovered that the shaft is bent. So here at the position of the bearing, we're talking about 4 thou, maybe 4.5 thou of total run out. So I'm going to have to think about that. This isn't a setup I can use to tidy this up. I'm not sure that that run out is acceptable. Well, I've decided to cut this off and attach a new section on the end here which I can turn to size. But in order to do that, I've got to extract the bearing, and I've already had a go at this and it's pretty tight. So I don't yet have a press of any kind to do that, so I've made this extractor tool. It has a base plate with a hole in there to go over this shaft, a landed area there to make sure I pick up the inner section of the bearing, and that slots in like that, and then an end cap with a little recess there which goes on the end of the shaft, and I'm going to use that to pull this off. Well, having got the bearing off and thinking about how to correct what I thought was a bend in this, I realized that it's going to be a little bit tricky to join these two together, considering that I don't have welding facilities. At the moment I'm not able to silver solder, so that was restricting me really to interference and adhesives. And that was proving to be a little bit tricky. There wasn't a lot of material to play with, so I thought I'd just put this back in the lathe, and discovered that the run out is actually not too bad at all. That's about 3/4 of a thou at that point, and then here just a tick really, it's sort of about 1/2 thou, maybe even less. And the bend which I thought I could pick up before isn't there. So what I'm going to do, in fact what I've started to do, is just skim this, and so I've skimmed the end here where the damage was, and a little bit up at this end as well. And having skimmed it, I find that the pulley fits on. So here we are. So that fits over nicely. Maybe a little bit tight, but I want it to be tight. And that's not running too badly actually. That's not run out there, that's just dirt. But that's not running too badly at all. In fact, I think it would be a bit better if I get a bit further on. But anyway, the long and short of it is, I don't need to do any more to the shaft. All I need to do now is to put keyway in here, and this is ready for reassembly. Okay, so I previously established the vertical height of the motor, and I've got this scribed line here which marks the top of the mounting plate. So I produced this little template from the mounting plate, and I've got the 4 holes on there and the upper extent of the plate itself. And what I discover is that unfortunately, if I put this in the center, which ideally it should be, that the holes come right in the center of these 2 holes and here, so there's no material to work with. The top 2 holes are fine. That's virgin material, so I can just drill and tap that wherever I want. So what I really need to do is bring it to one side so that I can bring the hole in the center of this here. If I plug that and maybe open this out and plug this as well, then I can put 2 new bolt holes in there. So I've produced this drawing, and from that you can see that when I'm using the highest or the lowest ratios, if I move to the center of this hole here about 10 or 12 millimeters to one side, the belt will still clear this shaft. So yeah, I'm confident now that I can go ahead. If you look carefully, you can see I've already had a go at tapping this. This is a 1/2 inch hole, and I found that 5/8 Whitworth taps, that's almost the right size for a 5/8 Whitworth tap, and I have had a go already just off camera just to make sure that I can indeed tap this. So I've gone far enough to prove the point. The rest of it I will do off the machine. So I'm going to remove this, finish tapping this, open this out to a suitable size and find a suitable tapping size for that, and make a couple of plugs. This is 5/8 Whitworth and this is 7/16 Whitworth, and I've cleaned out the holes and the thread, and we're ready to glue those in. So I can get the hacksaw up close to the body. Okay, I think we'll go and have a coffee break now, come back and then machine those flat. Okay, I've set the mounting plate up in 2 vices and just clocking this in to make sure it's running parallel with the table, and a little bit of adjustment like this. I think I'm nearly there. I'm not going to use a larger shell mill, which I have, partly because this setup's a bit on the delicate side, and also I just need to machine where the feet go. So I'm going to start just by bringing these down and making sure that these 2 sides are flat, and then I'll traverse across and just see if I can touch up these areas too to make sure I've got a flat surface for mounting. Just marking out the positions of the feet now so that I can mill those areas flat. I'm just transferring the centers from the foot of the motor to the base plate, and then I'm going to center pop the remaining 2 holes, and we'll go over to the drill and drill these out. These are going to be tapped 6mm. I'll just circle those holes to make sure I don't drill in the wrong place. So I wanted to settle this once for all. What is the issue with this? So I put the shaft back in the lathe, and I know that my chuck is true, and I've picked up the center, and I'm detecting the run out, which originally led me to believe that this was a bent shaft. Now, having trued up this end by supporting the bar in the chuck and traversing down here, so we don't have a damaged shaft here, we have a shaft that is reasonably true. What I find is that the run out is in the same position, so that's the maximum. Maximum is about there, and if I traverse down to this point, again the maximum is around about that same position. And if we come on to the bearing journal, we can see again it's roughly the same position. So what I conclude from that is that actually the run out was the center. The center isn't true with the axis of the shaft. So that's what I'm picking up. So the shaft isn't bent, and when I turned the shaft in the chuck, dispensing with the center, I got the opportunity to sort things out. So that's what actually happened. So when I supported it like this, I ended up with a shaft that was true. So it's not bent after all, it was just that the center wasn't on the axis of the shaft. So that's happened to me before. You see a center, you just assume that that center was used in the finishing stage of the manufacturer, but it wasn't. It must have been used at some other stage, but certainly not the finishing stage. Or it could be that the center was damaged, but I can't see any obvious damage. Let's have a closer look. I can't see any obvious damage there. It's just simply that that center is not concentric. So I'm just dismantling this assembly. I want to get the gears off. I've removed the bearings already, and want to get just down to the shaft so that I can work on this area here. This is the area where the old seal was rubbing. When I install the new seal, my new seal is a double lip seal, so it might well straddle that, but still I think there are scratches here which it would be good to remove. So I'll strip this down and we'll put it in the lathe and just see if we can polish that up to give it the best possible chance of working. So I've got a piece of wet and dry wrapped around a piece of gauge plate to provide a backing, and I'm just polishing this up. Already I can see a difference. Might try a little drop of oil on this as well. Definitely feels smoother, but I can feel that ring there. I think what I'm going to do is try and arrange for the two lips on the new seal to straddle that line. Definitely an improvement. So on the left hand side of these two pictures you can see the shaft as it originally was, and on the right there after polishing. There's a distinct improvement, but the original line is still there. I'm not sure whether this surface finish is good enough, but we'll give it a try. I ordered a new oil seal and it's arrived. This is the new one, that's the old one. The difference between them is that the old one has just one lip and this has two. And fortunately I produced a drawing of the old seal and its housing, and I noted the position from the end of the housing to the lip. So what I can do is push the new one in to the housing and make sure that the two lips straddle where the old one was, so I don't pick up that slight imperfection in the shaft. So that means that the two lips are now straddling where the old seal was. That's ready for installation. This Arbour press is really saving a huge amount of time with refitting the bearings and pressing things back into place. Well, I'm starting to reassemble everything. I put gasket sealant around here as it seats on this casting and also on this cover. I took the cover off to make sure that the bearing was clean, because it's the lowest point in the sump here and there was quite a bit of dirt in there, so I flushed that out. So we're ready now to reassemble, and so this goes downwards through the seal we've just installed. I think I have to press that in. So this is a bit fiddly. There's a couple of ball bearings which form a detent on this flange shaft, and I can see this is going to be very easy to lose these little ball bearings with the spring tensioning it from the inside. So let's hope I can do this, but I managed to do it without losing the ball bearings. This top bearing in as well. I remember this was particularly tight, so we'll see if we can get that in. That is tight. Now this has two set screws, a locking one and then the one which actually engages on the shaft, and really the smaller one should go in the bottom and actually engage with the shaft, and the heavier one with a longer depth of thread should go on top to provide the locking force. So just put those in, just waggle this around to make sure it's seated. And put the locking set screw on top. Okay, these 1, 2, 3, 4 go right through. In fact, 1, 2, 3, 4, 5 go right through into the lower casting. So the others are just shorter screws, just to hold the cover on. And these two are jacking screws, so we don't need anything in there. Before we get any further, let's just check that the belt will reach across. Yeah, I think there's going to be plenty of adjustment in there. The lubrication plate here says 1/3 to 2/3 of a pint of Shell Tellus 32. I've got the modern equivalent here. If we go for the 2/3 of a pint, that's roughly 0.4 of a litre. So what we'll do is we'll put 0.4 of a litre in, and while we're waiting for the next video, that will give time just to see if this seal holds up. What used to happen is that over a period of 2 weeks there'd be several drips would come off the drill here. What would happen is it would go through that seal, down the quill, through the bearings and out the bottom. So we'll see if that holds up. So that forms a convenient break for this project. The mechanical work on the Meddings pillar drill is done. The pulleys are properly mounted on their shafts, and the oil leaks hopefully are cured. You'll have noticed this lump of cast iron and steel on the bench here. It's very heavy, but it's a very useful addition to my workshop. I'll talk more about that in future videos. Next video will be sorting the electrics out on the drill, the VFD drive, and I'll test it. An update on the Colchester student lathe that's ready to be collected from Pakistan this coming Monday, and will be making its way back to the UK, and I think that will take several weeks. So I'll make that the subject of a future video, packing the lathe up, shipping it and bringing it back here. That might be of interest to some of you. So thanks for your support, thanks for your comments, and I hope to see you next time.